Hello everyone, welcome to the fourth episode of the Working Software series. In this episode, I will talk to you about scripting, about how to invent a new scripting language for your own application. First, I will tell you why you would want to do such a thing. What are the reasons to discover, to invent your own scripting language? And then, I will show you a short demo of one application which I am developing right now, so that you can see how it works in practice when you do have your own language. And then I will effectively develop one language for you. So let's start. Why inventing a language? Why scripting anything? The reason is both simple to understand and complicated, hard to defend in practice. Namely, by scripting anything, you're making that thing, that application, that component, whatever it is, extensible. You can extend its operation via a script, and the script can be written months later by a user who has installed that component on his or her computer. So when you are writing an application, you are allowing a third-party script to be injected into your application. You're allowing someone to modify the way your application is working later in ways which you might not have predicted. Now, that is already a bit suspicious. What does it mean that you have not predicted the way in which your application will be used? That's not what you should do, actually. You should predict legal ways of using the application and then support scripting, which lets your user extend the application in those legal ways which you have predicted, actually. And then, why not building those things into the application? That is the core reason why making a script rather than making a UI. Everything can be done in a UI. If you imagine any scripting command, anything at all, there can be a UI element which accepts parameters and has a button, do this. So scripting is not really necessary. Scripting is never really necessary. Scripting is a convenience. And it is a great burden to make it straight. It is almost invariably easier to make a UI than to design a language. On top of that, your users would have to learn the language in order to use your application. So there are many cons and only a few pros for you to create a scripting language. Therefore, if you are thinking about creating a scripting language, the first reaction, your first reflex should be don't. I only know about a couple of applications I made in my entire career that required scripting. I know of two of them, two industrial applications, which I was working on. One was insurance application. In life insurance, there are huge formulas, very complicated formulas which are calculating risks and probabilities, and you can design a UI for the operator who would design the decision formula for different events in insurance. But those people who are using that are already mathematicians. So why not just give them a formula editor and a keyboard and let them write formulas the way they would write on the paper? So that was quite natural for them. And also, being mathematicians, they would invariably understand what it means that there is a parenthesis missing. For example, those syntactic errors that the user might make would be quite natural for people in that domain. There was a second, yes, there was another application I made 20 years ago, which had some conditions that had to be executed in the database. It was the time of stored procedures, and that application would accept logical conditions which are cutting data, and those conditions were used to build a SQL query for the database in bulk update operations that would update tens of thousands of rows in one statement, in one SQL statement. What we did to make it extensible, we added a condition editor to the application, and that editor would allow very limited code, actually Boolean expressions, to be written there, so that those expressions can be validated and injected into SQL. Think about it, injected into SQL so that data can be updated dynamically. It was walking on a catwalk. But that is also telling you what is a bad idea about scripting. Every script is a security risk. Now imagine writing a script which ends up being part of a SQL instruction, SQL statement. Will somebody drop table because you forgot to test something? That is risky. So avoid that whenever possible. That remains. And then come two applications which I'm working on right now, which both require scripting. And these applications really require scripting because they are very rich. One of them is, we will get back to this Parser repository. One of them is LiveCoder. Here it is, LiveCoder. LiveCoder is an open source project which builds a Visual Studio extension which helps you hold live coding presentations using Visual Studio. I'm using this extension in all my live coding talks. It is very easy to use, and it's letting me hold presentations with a lot of code. I can write a lot of code by writing the script which will effectively inject code snippets particularly, so that I don't have to write anything while I'm giving a talk. This extension was already presented in episode 2, where I was talking about processing plain text. And back then I think that I said that I don't like the way this application is working right now, because this application is actually replacing Visual Studio code snippets. It is historically done that way because I started holding talks using snippets. But I didn't like the snippets engine in Visual Studio, so I made my own, and that is the one. I want to invent a proper language for holding live coding talks in using Visual Studio. All right, that is the project I'm working on. And there is another project I'm working on, and that is the tool which helps authors record video in video courses. Since I am recording a lot of video courses, recording and editing video is a painstaking work and I wanted to automate it. So what I did was to automate any application at all, so that I can write a script in my own language, which is pretty simple, so that I can eventually just start recording the screen and run the script and move away from the keyboard, because if I'm touching something, I will actually mess up the recording. This text here is an example source code on which I'm working right now in one of my courses, and I will run the script for you. Unfortunately, I will not be able to show you the script itself, because nor will I show you the application which is running it, because that technology is not open yet and it's not ready to be. You should not see. Anyway, I will run it. I have only one shortcut on the keyboard, which I will press, and you should watch this window here. The script has initialized the script into its proper initial form, and now watch what will happen. It will start typing for me. Look at my hands, nothing. I could start recording, and this recording would become part of the video course with almost no video editing at all. Look at this. The script parser will start, for example, typing code with the same speed and same pauses between buttons that a human operator would make when typing code. So this this tool is executing a video recording script mimicking a human operator. If you watched a recording, you would think that it was me typing on the keyboard rather than an application running a script. Okay, I will fast forward this. Okay, this is the final look of the source code when the script ends. So this was the demonstration of what you can do when you have your custom script. And this is the application which really requires a script. And so if you found an application for a custom language, how do you implement it? I will get back to this live coder, and I'll tell you, I want a scripting language which is simple and expressive. It must do interesting things. Let me step to, this is a Hello World application, console application. So what I want to do in my presentations is, for example, to open the program CS, to go to the line which contains this. So this is the declaration of the main function. Select this, for example, and then press delete. I want a script. I want to script this, because that is what I might want to do in a live talk. And I only want to have a presenter, one button, which says next, next, next. And I want to talk. I want coding to be done instead of me doing it. So I need a very simple scripting language. That language, so what is the point of this demonstration? I want to start developing a language which makes sense as a proof of concept, and then I want to move that language into and to put it into this project, this live coder project, so that it becomes the second supported option in this demo runner, so that you can choose, if you are using this in your live talks, or anyone who's using this can choose whether to use snippets or the script. That is the idea. So let's start. This console application will be the application in which I will demonstrate developing a proper scripting language. And for that matter, I will create a new text file here, which will be the demo, which will be the testing script, input.txt, for example. And I will always copy this to the output so that we have some text file available when the application runs. All right, so imagine that your end user has injected this text file, supplied this text file to your application, and your application needs to do what this file says. The script will be here. For example, what was that I wanted? I wanted to edit file named program. Since this is the program CS, the only one that has that in its name, word program, there shouldn't be any confusion. Then I want to find a line containing this. Look what I'm doing. I'm inventing a language right now. Line containing this. If you saw this script for the first time, I'm sure you would understand what it means. I want to select this, and I want to delete it. This is the script. I want an application which can execute this script. It means to understand it and to run specific commands. Each line should compile, all right, I will tell it that way, compile into an object, an in-memory command object, which will do something to Visual Studio, like checking whether there is a selection, and if there is a selection, press delete. How can you develop a language like this? That is one question. And an easier question, why would you develop a language which looks like this, like almost like a spoken language, and not something like files.find containing program semicolon? Why not script like this? And here's the answer. These things already exist. You don't have to invent them. If you want to write script like this, it means that you are talking to programmers. Then give them a DLL, give them a library, and let them write a C# extension. If you want it to be dynamic, let them write Python extensions. And when you do that, you're opening a security hole size of a bus. If you are allowing source code to be injected into your compiled application, then you must sandbox that engine, whatever it is, that component which is executing scripts. You must sandbox it so that any damage a user might do on purpose or inadvertently remains locked into that component which is executing the script. The damage must not spill over into the rest of your application. It must not drop your tables. No. It must not install applications on your disk using your privileges. It must not connect to network servers and stuff like that. That is a huge issue if you want to make your applications extensible using high-level languages. And I'm not going to talk about that. That is a large topic on its own. There's a lot of resources on the internet, and you can learn that if you wish that. A hint, I have never, ever implemented this in my life. I never needed. There are reasons why you would want to do that, and my first pick would be to use Python extensions for that kind of scripting. All right then. Then, why this kind of scripting? Well, it is my choice. It is my preference. You may not agree with that, and you can do it this way or the other way, whatever you like. My choice is, if I'm making a scripting language, then I want it to be human readable. Very easy to read, very easy to understand, because you will be writing scripts. You don't want syntax errors like imbalanced parentheses. You don't want that. I don't want to use parentheses at all. But on the other hand, there is an important aspect of this, of producing any, inventing any kind of script. It must be uniquely understandable, compilable, parsable. For example, if I made an instruction named edit and then the name of the file, then I must not make edit new program. For example, an instruction which is creating a file, program.cs, for example, let's be specific. If file program.cs doesn't exist, create it and then edit it. What is wrong with this? With this instruction? This script cannot be compiled, cannot be parsed, because it is not deterministic. When you see edit, what comes next? Keyword new or file name? If you don't know, then nobody knows. Computer doesn't know. Is this the file name? Exactly. Rascal, thank you. That is the correct answer. Confusion editing a file called new, or more specifically, new space program.cs. New space program is a valid file name, and therefore there are two ways to understand this instruction. Edit new file named program.cs, or edit a file called new program.cs. Your scripting language, whatever it is, no matter how small and simple it is, must be deterministic. And there are many ways to avoid this confusion, like edit new. Now we have a keyword edit new, which means that dash is not a minus. That this language doesn't have arithmetic operations. If it does, then use an underscore or use nothing. Edit new. Make unique keyword for this purpose. Okay? So your language must be deterministic. And when it is, then you can make a lot of different instructions which are reading like a text. And that is what I like when making scripts. I like them to read like a plain text. For one very simple reason. When you are the user, when you are editing text, editing the script, you will have to read it, and you must be certain that it is correct. What if I made a typing mistake like this? If I used any text editor, virtually every text editor today has language validation, and they would underline this for me, and I would have to fix that. It's very good to have a spoken language as your scripting language, because you will have free help from the tools. And on top of that, language must be deterministic, and that is accomplished in a very simple way. Make sure that every word that comes next is deterministic. Edit means exactly one thing. Edit and space, and whatever comes to the end of the line is the name of the file. Done. Line is always followed by containing, followed by a space, and everything to the end of the line is the content. Select is a single keyword followed by a space followed by content. Delete is a single command. If you observe this, there are no confusions. Every word here means exactly one thing. And if you can accomplish that, to make sure that one word means one thing, one word can mean several things, but the context in which it is used, all the contexts, must be deterministic. A word like line containing or file containing static void made. There's no confusion because containing is coming after a file or after a line. If you understand what it means, line then containing, file then containing, you're all right. Containing line something, containing file something, this is also all right. Because in all these contexts, you know exactly containing, and there is a single word telling what, containing what. And then there is a free-form content. It is not possible to say containing this because now file could be part of free content. So I think that you've got the grasp of what I'm telling. If you can understand uniquely what a line means, then the computer will understand it too. Next, I said a magical word a few seconds ago, line. You don't want to separate your instructions this way. That will complicate your model, and that will complicate the conceptual model in the heads of your users. Make one line, one instruction. Make instructions short. One line is something to do. Done. Okay? So I'm constantly leaning towards making simple scripts. Very simple as possible. So that you can just look at this and say, yes, this is what I want to do. This is correct. These are my instructions. And so we come to the question, how do we implement this? How do we run this script? This is plain text. I could go to this and say, file, read all lines. It will be the input.txt. I can write it like text is string join with new line. Okay, I can see this. Let's run and see if everything is all right with that input.txt. And then we will start first step. Yes, this is a text file. Then we will step to trying to process it, turn it into objects, and to execute these operations, these instructions. For that, I will use the parser that I made, easy parse, and in a way this demo will also be an instruction manual how to use the easy parse library. I made it because I didn't like what existing parsing libraries and compiling libraries for .NET or in general are doing. They are too complicated for the purpose which I see for them. For this purpose, making small, simple scripting languages. They are good if you want to make a large language, but you won't want to make a large language. If you want to invent a proper programming language, then this is not a presentation for you. There are books about that. There are much more complex talks on that topic. If you want to do simple things, then you want to have a simple solution. You don't want to have to understand compilation theory, syntax trees, and stuff like that, so that you can just execute. Where is execute this? There must be a simple solution. So if you take this, if you download this code, you will find two things there. One is the library, which you will have to add to your program, which will implement this script, which will parse this script. And you can do that through NuGet. This is, where is NuGet? Here it is. I have already searched for it today. So you can just look for Easy Parse, and here it is. Coding Helmet Easy Parse. And it supports .NET Framework, .NET Core 3.0, and .NET Standard. So in any kind of project, you can add this. And it says go to that GitHub repo and read how to use that. Another thing that is very important in this library is that it comes with a command line tool named Parser, which will help you generate parsing tables for your grammar, and it will help you develop the grammar, for one thing, so that you can emulate it. You can try your grammar to see if it works before you add it to source code. Let me show you how that works. This is where that demo application is, and here is the input txt. In order to parse a text file like this one, you need to have a grammar. So I will add a grammar here, and I will call it that way. New item text grammar txt. And if you look at the explanation here, this is the format of the grammar. If you watched episode 2, I was talking about lexical analysis. Lexical analysis is the step which precedes compilation of any plain text, and it means to separate elements of plain text into lexemes. So in this implementation, you will first list what the lexemes are, then you will tell what the starting symbol is, what the starting is, and then you will you will design rules, will specify rules. So let me show you that in this practical example. So it is lexemes, start symbol, and rules. These three blocks must exist in this grammar definition. So this is the grammar definition in my library, in Easy Parse library. It is doing both things, lexical analysis and parsing. And there is also an implementation of a compiler which is leaning onto this grammar file. You will see all three of them in this demonstration. So your grammar needs to script needs to specify what it means to have a script in the file. And I will call it script. I'll call that root element script. This requires at least some understanding of grammar notation. If you have any prior knowledge of grammars of formally specifying programming languages, then you will certainly recognize this. I need to specify what the script is. And then comes that simplification, which I already mentioned. Script consists of lines. So the script is a line. But script can have multiple lines. So it is a script followed by a line. And what is the line? As of now, I will say that it is an empty line. And so the time comes that I show you how this works. Let's do this. Parser is the tool that comes from that repo. You will have to build it and put it somewhere where you can run it. And it says grammar is grammar.txt, and what do you want to do with it? For example, I want to emulate it, and this instruction is not complete. A few days ago, I have added the multi-line option too, so that you can emulate the parser, the grammar, on a multi-line input. So I'll just enter a couple of empty lines because I'm currently only supporting empty lines. Control Z is the end of input, and here it is. If you know anything about compiling, this is the syntax tree. It says it has recognized a new line, and it has recognized that this new line is a line symbol. And this line is a perfectly valid script, because script is either a line or a script followed by a line. Right? So we have a script. Here it is. This is the script. Then there comes another line, and you know that script followed by a line is also a script. And so on recursively. Another script, another script. Yes, and this script consists of this script and a line. How do you like this? I have just explained a file consisting of empty lines alone in what? 9 lines of text. And I can start building the whole language out of this. A language which will define this. But I'm not ready to do that yet. To do that, I need to start from something very small. For example, it's always a good idea to define comments first in your new scripting language. Just put everything under the comment. And then I will define a comment which matches. This is the verbatim string marked just in C#. I will provide a regular expression which explains a comment. It is a hash followed by anything. So the line can also be a comment followed by a new line. Let's try this. I want to copy this, move to the emulator, paste it here. It works. Look, hash followed by anything followed by a new line is a line. You see, everything has been treated as comments. It works. Let's speed up a bit. What if somebody writes this? Or a tab and a couple of spaces. I'm assuring you that this will not work. Unexpected input. There is something here and it doesn't recognize it. In any scripting language, you must account for white space. A very easy way out of this problem with the white space, because if you think it through, white space is a hell. Multiple. What does it mean to have 3 white spaces followed by a tab followed by 4 white spaces and a new line? It's very complicated. This language, or this grammar language, also supports ignore lexemes. I can put here a regular expression which says what to ignore. And I will say white space, space, or tab. Multiple spaces or tabs are ignored. Just ignore them, like they were not in the file. Let's emulate this. And now it works. And look here. There was, at this line containing, this line had white space, but that white space doesn't exist here. There's no white space here because it was ignored. That lexeme was dropped before parsing. Okay, let's support real commands. Let's support edit program. I will say that a line is also a statement followed by a new line. And the first statement will be edit. Edit will be a constant edit followed by, okay, that is a regular expression and I must declare it in the lexemes. File name matches anything, but it must be at least one. What do you think? Will this work? Will this work? No. It says that the first character matches nothing. And now we are in trouble. Why does it match nothing? Why doesn't it understand? If I said edit followed by something that is anything, and then followed by, that is the statement, so the statement is followed by a new line, why doesn't it recognize the edit instruction? It doesn't, because this regular expression is catching anything. It means that when it starts parsing edit program, it will catch the entire line edit program. And then when you read the grammar, it is just a file name. There would have to be something that only consists of file name, but there is no such rule here. You must never produce regular expressions that are catching everything, because you will never parse anything. All your expressions, all your regular expressions must always be specific. Not only in this library. This library is not special in this respect. Any parsing library you use, any language you make, you must be specific. And so, one way to make it specific is to use a so-called look behind. It is, I think this is the syntax. Look behind, so this must be preceded by edit and a space. And then anything that follows after edit and space, all until the end of the line, will be considered a file name. Now this is mind-bending, but only a little bit, because this is so typical in regular expressions. You will always bend your mind around expressions. And now it works, because it has found something that follows after edit and a space. And it has matched program, right? There is one nuance when speaking of look behind. Many implementations, including that one in Visual Studio, in .NET, not Visual Studio, request that look behind pattern has a constant, or not constant length, but deterministic length. If you read this, you must know how long this is. Let me show you where that will hit you. If I said edit large space program, my grammar says that spaces should be ignored. They should be ignored. This is edit program, all right? But if I emulate this, it will not recognize it, because it's not edit space program. I might try to do it like this, any number of spaces, but it won't work. It works, but it didn't work. Oh, I made a mistake. .NET supports it. The other emulator I used didn't support it. Oh, I'm lucky. I can implement this. Many regular expression implementations don't support this, so you have to try it on your own. Actually, I made a mistake not trying it in .NET, but trying it in an emulator, and it didn't work. So I will have to read about this. This is very interesting finding. Many regular expression engines cannot execute regular expressions backwards. And for that reason, they need to know how long the look behind has to be so that they can go back, select that many characters, and run the look behind expression onto them. And if that matches, if that text matches the look behind regular expression, then you have matched the look behind expression, and you can keep going, which means that there is an edit followed by a number of white spaces, and then you can select everything that is that follows. Sorry for confusion. It was my mistake not trying it in .NET. But anyway, I'm very happy to see that it works. Great. What about these? Let's support the line containing something. Okay. Line containing something. Where is my grammar? So I will say that there is a statement line containing. Line containing is constant line followed by containing. Now, think of this. I'm not specifying white space because white space is ignored. Anything, including tabs, everything will be completely ignored. Only the word line and the word containing will appear in the sequence of lexemes. So you only need to specify this, and then again I have that problem of saying, okay, containing content. I have to use another look behind, but this time I don't allow white space to be ignored. I want one white space to be ignored, and everything here is what you are searching for, because you might decide to search for 4 white spaces in a row. Maybe that line is what you wanted, the line containing 4 white spaces in a row. So I want to only ignore one space and select everything that follows. And that expression will be different from this in that it again has a look behind containing one space and then anything. So I can call it containing content. This is a bit complicated, but I hope not confusing at the same time. No matter how complicated it is to invent a language, I think it should be, I think that I have tried to make it as straightforward and simple as possible using this easy parse library. I don't know if I have succeeded in that. Anyway, line containing whatever. Let's try it in the emulator. This is very interesting error. I have got a syntax lexing error actually. Lexing error trying to emulate my grammar. Let me tell you a secret. I see it. This grammar is parsed using a grammar for a grammar. And that grammar is part of the easy parse library. Easy parse library has compiled a grammar, and grammar is being subdued to that parser so that you can build a parser for this. So many recursions. And what it said was that my grammar has a lexing error. So I've put apostrophe at the wrong place, and that was lexically incorrect. This has not. This was an unknown lexeme in the grammar. If you want to know what I said, go on and read the easy parse library at GitHub, and you will find a grammar that explains grammars. Why not showing you that? It must be here. Here. Grammar compiler, see? Here is grammar. This is the grammar Is it so small? Maybe this is the entire grammar. I don't know. Maybe it is. So here are the regular expressions explaining quoted string, verbatim string, non-terminal, terminal symbol, everything. And there is a grammar which has a start and lexemes and rules. Rules consist of rules and a rule. Okay, so this is the grammar which is explaining the syntax of this grammar. And when I make mistake in this grammar, emulator will fail. Why? Now I have no idea what I'm doing. Oh, except I have an uncaught exception. I will debug this. Oh, so many surprises today. And now it says select is not expected. Why? Containing followed by anything. What about white space here? I will have to think of that. Let's try a simpler example. This is typical when inventing languages. You will find a lot of special cases. Yes, now this works. So I have a problem with deleting white space in that what I'm selecting. Okay, I will think about that later. When you are working with regular expressions, you have to test them a lot. And you must cover all kinds of corners. You will encounter many special cases. So it is always difficult. But okay, now I know that I have a feature which I don't know how to support. I will have to think about it. Let's move on. Select statement. Let's support select statement. So it is statement is select. Select is select content followed by again some select content. I would have to introduce another regular expression which is very similar to this. You can do that, or you can take a different course of action and say, let's make a so we obviously have commands that have something followed by something else. Okay? By something particular followed by something that is not known, followed by anything. You might choose to put a separator between these known keywords and unknown content. So all statements in my language from now on that have an unbound content following to the end of the line will have to have a separator before. And that will make my life much easier, because I will only look for a semicolon, for a colon, followed by a white space, and then capture anything that follows. So I have just stepped away from that human readable stuff and made a sacrifice. You can choose not to do that, but then you will have to create many, many very similar regular expressions. It's your choice. So I will select this, content, just content. And let's emulate this again. I forgot to put colon here. I have changed my instructions. They require colon followed by the content. Good. Now it works. Look at this. Edit program. I have not used that content in the program because I wanted to trim white space before the file name. In every other case, I don't want to trim white space, so it has caught this. What if I put white space now? I want to try this. I still don't know why that didn't work. I will have to think about it. No, it definitely doesn't work. Oh. This is puzzling me a lot. What if? Because dot should. Oh, I know. Oh, bloody hell. Do you know what's happening? White space is being ignored. It has been recognized as a lexeme. I think this is a hypothesis. So what if? Oh no. I would have to include white space followed by colon, preceded by colon. Too complicated. This is a hypothesis. I'm not certain that is the bug here. But again, that is what you get for free when you use regular expressions. Your head will explode sooner or later. All right, let's finish the language. Delete. It's easy. Statement delete. Delete statement is just delete. Done. I could technically parse this entire file, and now it works. Minus those spaces. Sorry, I have a missing feature. Okay, so what is this? How do you read this tree, syntax tree? It is, you can read it recursively, but you can go from bottom up and build the larger elements, like this statement is an edit statement, which consists of an edit and the program. This edit, we know that it is constant, but this is a variable. We know that this is variable, everything else is constant. So when working with this tree, you want to extract these, but what do you do with them? Well, that is what their parent tells you. Select this. Just delete. Line containing this. Statement. Edit this. That is why I had to separate all different statements and give them names, so that the syntax tree will have elements, have nodes named edit, line containing, select, delete. And now you know what to do with all that. I will briefly show you how you can parse, but just to tell you right away, you will not parse. You will not do this in your code, which I will show you. Parser. There is a parser in easyparse.parsing from XML resource. I need an XML file which represents the parser. In order to have a parser in your application, you have to go to this grammar and compile it. Okay. And now you have a grammar.xml. This is the parser definition, which is my schema, and I know how to use it. This EasyParse library has the parser which can load this file. In order to load it, you will have to include this XML file as an embedded resource into your assembly, which you will execute this. So basically, you can pick type of program assembly. In this assembly, what is the namespace demo, and what is that was named grammar XML. You can load the parser. Here it is. And now you will have the parser which will execute this grammar on whatever input you give it. If I run the application, so it's very simple. The idea was when I made this library, the idea was to make its use trivial. Don't think about parsing. Don't think about compilation. Parser, it has a lexer, and it has reduce table, 44 rules. If you know anything about LR parsers, they consist of shift and reduce rules. So there are 20 shift rules and 44 reduce rules. You don't have to bother. I'm showing you this just to show you that I do have a parser for this grammar. And now I can parse these lines. And that will give me some parsing result, which I can print. But you see, it is a parsing result which either contains parsing error or a syntax tree. Let's run it on the input.txt file. Come on. Yes, it works. Here you can see the syntax tree. It has read this file and it has parsed it correctly. If I made a syntax error, like line, colon, the parsing result would be a failure. Come on, unexpected something. Let's see. Unexpected element at colon is unexpected. So that is how you can parse text in your application and see if parsing succeeded. And you can also compile and give it a compiler. Actually, you will rarely care about what this parsing result is, except if you want to display an error, but also compilation would pass the error out, so you don't ever have to test this. You can simply compile it, but you need a compiler. Compiler is a component which is transforming syntax tree into some other form. It can be a file on disk. Like when you're compiling your source code, you will get an executable file. But it can also be an object in memory. And when you are writing languages to extend your application, you will wish this latter form. You will want to load a text file and have an object in return. That is all you want, because you know how to operate on objects. And you want objects to be of very high definition. So I will show you how a compiler can be written using EasyParse library. I will create a namespace called scripting, and I will put both of these there so that the program doesn't have to think about those. Of course, that has changed the namespace here, scripting grammar. Okay, that is fine. And all you need to do is create a compiler class which derives from method map compiler from that library. There's nothing to override. And you will just give new script compiler to this compile, and you will collect a result. But now comes the magic. Method map compiler is receiving those three elements, those three nodes, and it is looking for methods named the same. For example, there must be a method named edit which receives a string which will receive value added here, and a string which will receive a value program. There must be a method named line which receives something, I still don't know what, and a string which will be a new line. If you can make those methods in the method map compiler, your own custom compiler, then the method map compiler will use reflection to map all nodes of the syntax tree into calls to your methods. It will pass parameters, their arguments, these child nodes, and you will know what to do because that's your language. And whatever you return, the compiler will return back. I'll show you that. It will be very simple. It will be astonishingly simple. You would, in effect, what your compiler implementation must look like is this. That it must look the same as the grammar. So I will just copy the grammar there. And I told you already, you can understand the syntax tree by reading it bottom up, by building larger nodes from simpler nodes. So what is the delete? That will be some delete instruction, which means that I need an object of class instruction. I'm turning the syntax tree, that abstract thing there, which doesn't know about concrete types like string or integer or stuff like that. I'm turning that into objects because I want objects in the end. You always want to compile into objects. So it will be an abstract class, all right? But there will be, you can keep all methods private because reflection can find them anyway. There will be a private method which returns an instruction and which is called delete. Its name is delete. And it must receive a single string which will always be delete. That is the constant in my language. And I will ignore it. I will just create a new delete instruction, which I still don't have. Let's make it. Delete instruction, which is an instruction. So let's get back to the compiler. New delete. Done. I have supported this rule in my grammar. My method map compiler will find, when it encounters a node named delete, a non-terminal symbol named delete, it will look for the method named delete, which receives a single string because it has already a single string node, delete. It has a single string node, which is a string. So it looks for the method which receives a string and is named delete. And you are free to return whatever you like. I choose to return instruction from all these instruction rules. You will see how we will combine instructions into a script very simply. So, private, again, instruction, select. What does it receive? It receives a string which will always be select, but then, okay, string colon, it will also receive a colon, but then string content. Well, that is something. And since I know that there are a couple of instructions that are followed by content, I will create another abstract class, which is an instruction, which will expose content through a protected constructor, so that I can create another select content instruction, which will be a special kind of content instruction. Do you see what I'm doing? I'm building the entire object model, which is one-to-one related to the grammar, because that is the language I'm speaking. And I want objects to represent elements from that plain text. I like this very much because I have already made a couple of scripting languages which are not important to show, but very simply, where is the compiler? Okay, so I will create new select command and pass content to it. Now you see, I have received content from plain text and I'm remembering it in an object of a strong type. That is the point. Okay. Line containing consists of string constant line, string containing, string colon, and string content. Okay. So let's invent another instruction, line containing. which will be content instruction, which has a constructor. And while I'm here, let's create that last one, edit file. Okay, edit file will not be a content instruction because it has a public string file name, a more specific thing to think about. So file name will be initialized from the constructor. Okay, that's it. Let's get back to the compiler and say this returns new line containing content. That's it. And edit private instruction edit will consist of string edit and string file name. So this will be a new edit file. That's it. I have just compiled all specific instructions. And now I can implement the statement rule very easily. But there is a trick there. Private statement. No. Instruction statement. Statement node will always produce a single instruction. Do you know what it's going to receive? In all concrete instructions, I'm returning an instruction object. So what this compiler will do will be to build from bottom up. This is string, this is string, this is string. So there must be a select method which receives 3 strings. Do I have it? Did I call it well? Yes. 1, 2, 3 strings. And it will return something. In my case, that is an instruction object. But then there must be a statement method named statement, which receives whatever was returned from the select method. And that will be the instruction. And since I have nothing to do with this, I will just pass this instruction out. And all these 4 rules have been covered. The result will be that this entire node, this node will be represented by an instruction object in memory during compilation. And then we will hit the line rule, which says line will also be an instruction, okay? Which either receives a string which is new line, or a string which is comment, and now listen, statement will always return an instruction and then a new line. Are you following this? So there are three kinds of line nodes which we can recognize very, very easily. I have covered this. A single string, 2 strings, or an instruction and a string. And if you just see the types of arguments, you will know exactly which form of line it is. Now, both of these should produce an empty instruction, an instruction which does nothing. In many cases, whenever you create a language, you will invariably need something that is an empty instruction. You will always need something like that. An instruction which does nothing. Okay? And I can even go to the instruction and put public instruction, public static instruction empty. Okay, which returns an empty instruction. Very simple and very useful, because now I can go to instruction and return empty. Instruction and return empty. These 2 lines produce no instruction. But this one does, and that is the instruction which was compiled below by the statement rule. And so we come to the script. Script will be the topmost, that is the entry point in my grammar, the topmost call. It is the start symbol. that will be the result of the entire compilation. So I have to support scripts. I will create a class called script. That's it. But when you're compiling this way, everything must be immutable, because you see the script in the grammar is recursive. It supports adding something to it. You can add to a script and return it, but will you make a bug? I'm not sure. You can make script this way. Okay, I will write it in the compiler and you will see what I want. Private script. This will create the script. What is the line constructing? Always an instruction. So you know if there is an instruction, then you can create a script containing that instruction. Otherwise, the other form of script is to already have a script and an instruction to append. And now listen, I want script to append an instruction. I want an append method on the script so that I get a larger script with an instruction added to its end. And here I want to start from the script script.empty. I want to have an empty script and then to append an instruction. Okay, this is what I want to have in the end. And that will replace both of these. Let's implement that. Script. It's very simple if you put it that way. Public static script empty. New script. Done. Internally, since it is immutable, it will have an immutable list of instructions. That will be the script, a list of instructions. So I will need a constructor which is initializing this, which will complicate the empty constructor. It will have to receive an immutable list. And now you have an empty script. An empty script, and now look. Now I can add the append instruction, and that will be the new script with this instructions add instruction. Immutable list returns a new immutable list with one element added to its end. This is the immutable script, which can be the result of compiling that plain text. And when said that way, you can do a very interesting thing now. Look. Do you remember the empty instruction? What if somebody wanted to append the empty instruction? Just don't append it. Return this. Do you remember that ignore the white space? This is ignoring white space only in terms of instructions. This will ignore comments and ignore empty lines. And now we have the compiler done. It compiles. I can use it. Where is my program? I will not print this. I have compiled using the script compiler, and I have obtained some result. Let's look into the result. What is it? When we run this, I'd be lucky to have the compiler running from in the first attempt. I have made unexpected. Where? Oh, really? I didn't remove this. Good. Do you know what the compilation returned? The result is a message, unexpected element, colon, at location 23. By the way, this error is not written correctly. I have found another bug. It should be line 2, position 1. Internally, in that EasyParse library, I'm already supporting single line and multi-line texts, and I already know the precise location, but for some reason I didn't pass it through the entire stack, so the message is useless. You would have to count letters in your entire text to find where the error was. I will correct that. That is the bug. But anyway, after fixing the input txt, look what will be the result of compiling. Let's see. Yes, a script object containing 4 instructions, edit file line containing select content and delete. Effectively, I have turned the entire text, plain text file into an object containing 4 other objects. And the last thing in this demonstration, what will you do with this script? You will run it. Whatever this application was, there should be some button to run. Somebody would give you the script, the user would give you a file with the script, and you would run it. And running would compile that file and either report an error or keep going. This is the idea. If result is script, then you would do something. Okay, I'm successful. Else you would right line the result, whatever it is. There is some error class which you can convert to. So let's make a bug again and we'll see. Let's make a bug in the script. Now I'm making bugs in the script language, not in C#. That's funny, at least to me. Okay, so it is reporting an error. All right, but what if this was successful? It should tell me that I'm successful, all right? Success. So what do we do on success? It's very simple. Now you have the object. Now you do whatever you want. Public void run. Even better, return an object of a class running script. What it will do? It will run through the script and it should execute those instructions, let you execute them step by step. For example, let's imagine that we want to be able to run instructions line by line. How do we do that? Well, accept an instruction enumerator. Okay, let's initialize it through the constructor. So the script would give its enumerator to the running script. Okay, this instructions get enumerated. A note here, if you're using immutable collections, they will return an immutable enumerator which you must never pass to anyone, because that is an object taken from some internal pool of iterators, and if you do that, your function will explode. Instead, convert instructions to IEnumerable of instruction, and then return a common enumerator, generic, and that will work. You have to do this. If you forget doing this, your code will explode probably in the very first line, and you will know that you forgot it. Anyway, what does this script do? What does this running script do? It will, for example, tell you public boolean is over, get and private set. So this is over is not this enumerator, move next. You can write whatever you want, whatever your application has to do at this point, that is what you write here. And public void step. And then if this is over, return, just ignore. Otherwise, now enumerator current. I have a current instruction. Finally, I have an instruction object, and I can say execute. So the instruction would have to have execute. I will just write what this is. This might be 0. And I will move next. This is over, is not this enumerator, move next. So when you have the script object in the main, in the program main, you can replace this with while not script is var run is script run. While not run is over, step. Very simple. And what it will do will be to execute every single instruction in a row. Come on, executing. Edit file, line containing, select content, delete. By the way, that content instruction had a content. Let's override this so that you can see what it says. This get type full name and this content. Okay, and that edit file had a file name too. So let's see if we have them. Full name and this file name. So let's run again. Do we have those data from the script? That is the important question. Edit file program, line containing this, select content this. We have everything. Nothing was lost. All the textual information that was part of the script has been transferred into objects. And finally, execute, and with that we will finish. Execute. Where is the instruction? I was printing on the console. That is not very useful, right? How do you execute instructions? There comes another trick. Instructions always execute inside some environment. You will never execute instruction as an instruction. It will need something to which it can command. So what I will do will be to add an interface environment. And instruction will, in effect, receive an environment, and this environment would expose high-level operations such as find file, part of name, finding a file, void, find a line, string containing, things like that. That will be a representation of an environment in which you are running your script. And then you have to pass it from the running script. Where is my running script? Oh, it is in the script. I didn't move it. Okay, so here it is. It needs the environment. And therefore, this will need an environment. When the script starts running, it must receive an environment which it will pass to every single instruction. You see? Now you have a scripting engine built into your application. Of course, the script itself will have to initialize, where are you? Will have to initialize the running script. With what? With an environment. Therefore, now look at the division of responsibilities here. You have a script which is the result of compiling text file. That doesn't depend on where it executes. It depends on syntax of the script, nothing else. It will construct you the objects. And then there comes the running script, which will execute inside a particular concrete environment. And therefore, there is still a compile time error, because when I want to run the script, I have to tell where. And I will say that there is a dummy class here. Oh, it will have to have those functions. Yes. Don't throw anything. And I will have to pass a concrete environment to the script to run it. And the very last thing here, I want you to see this really run. This execute function should actually be abstract, not even virtual, but abstract. And every single instruction would have to implement it. For example, edit file would override execute, and it would find the file with containing this file name. Okay, this is a concrete, and probably do something with that file. So when we go to that nothing finding file, I will write to console part of name. And you will see this line, execution will pass to this concrete environment, asking it to find, here it is, to find a file containing program in its name. I hope you liked it. In this presentation, you have seen how you can define, how you can invent the language from scratch, from a blank page, how to create a deterministic programming language, scripting language, all right. Then, how you can write a parser for that, how you can write a compiler for that, and how you can execute the compiled object inside your application in a way which is very safe. There are no security holes here, because only the operations defined on this interface will be possible. Nothing outside of this will ever execute. So if you make a security bug here, that's your problem, but you don't have to do that. That's what I want to say. Make this very restricted. Restrict all the moves so that only the safe operations can be executed. And that's it. The end result is the whole grammar and compiler done in how many? 25 lines of code to define grammar, and compiler taking total of 33 lines of code, that is under 60 lines of code, to write the entire grammar and compiler for a brand new scripting language. What else would you wish for? So much easier than writing from scratch. Yes, Rascal, that is true. That is what I wanted to make when I started that easy parse library. I wanted everything to fit into 50 lines of code, because there are thousands of lines of code besides that, behind that. I don't want anyone starting with me to have to write that manually. I want a library to do all that and to be trivial to use. How do you compile? Where is my program CS? How do you compile? Load the parser, call parse, compile, get the object. That is your source code. 2 lines of code, which can be a single line of code if you want it. Okay, thank you for watching. If you have any comments, questions, anything, you can put them on YouTube when this recording becomes available. Thank you again, and see you in episode 5 next time. Thank you. Bye.